Hi everybody, I'm Professor Toner and I'm going to be your guide through this beginning math class. And I'm not going to cover every single detail as we go through each of these videos because that's what your book is there for, but I want to emphasize certain things. So I'm going to start right here in section 1.1 dealing with whole numbers, and I have a rather large number here on the board. And when you go to pronounce this number, you've got to be able to deal with what each of these different periods represent. This is 512 in the ones period. We have the thousands, the millions, and the billions period. So I'm going to read this as 19,456,327,512. Notice how I spoke that out. I did not say 512. There's no and in there at all. When we get to chapter 4 dealing with decimals, that decimal is going to be where we pronounce the word and. So don't use the word and anytime you're speaking things. When you're writing out the year, this is year 2015 when I'm writing or making this video for you. It's not 2015, it's 2015. Now let's talk a little bit about place value. For example, I'm going to underline this first 5 that shows up there, and I want to know what position is it in. For example, we've already said ones, thousands, millions. That 5 is in the 10 millions place. You have 5 10 millions, whereas this second 5 represents 5 hundredths. Okay, so we want to be able to recognize the place value of each of these numbers, because if we were to write this in expanded form, we would say this is 1 of the 10 billions plus 9 of the billions plus 4 of the 100 millions plus 5 of the 10 millions, 6 of the millions, etc. going through there when we write this in expanded form. When you start taking your numbers and writing them in words, we're not going to deal with a number this large, but watch how you write numbers, especially in these different groupings. When you're writing just 456, that's 456. And notice how I'm going to write the dash between the 50 and the 6 because it's a 2-digit number. You will use a dash between all 2-digit numbers from 21 up through 99, except for those single word positions like 30, 40, 50, 60. A note about the word for, F-O-U-R. When you go to write 14, there is a U in that word, but when you go to write the word 40, we do not have a U inside that. So that's just another mistake that shows up every once in a while that I wanted to call your attention to. Now, I'm not a big number line person, and I don't really tend to use number lines for addition and subtraction, but I do want to call your attention to it when it comes to using the inequality symbols less than and greater than. This first symbol is the less than symbol, and the second one is the greater than symbol. We would say that 3 is less than 5. 3 is smaller than 5. Notice how the small end of the symbol is on the left and the open end is with the bigger numbers. Likewise, I can say that 8 is larger than 6, or 8 is greater than 6. Now you've got to be careful when it comes to the negative numbers over on the left, something we're really not going to deal with till later in the class, but when you do so and you're comparing something like -3 and -2, notice how -2 is larger than -3. You'd rather only be in debt $2 to someone than $3 to someone. So we would write -3 is less than -2. Now, we don't just pay attention to 3 and 2, because 3 is larger than 2, but -3 is less than -2. Now, I don't want you just to have the skill down of being able to place the proper symbol in between two numbers when you're asked to do so. I want you to know that this first symbol is the less than symbol, and the next one after it is the greater than symbol. Now let's talk about adding whole numbers. You can add a string of numbers either horizontally, 8 plus 12 plus 15, and get your sum that way, or your total that way. Or you can add numbers by placing them beneath each other and adding down that way. If you're adding them vertically, please make sure that you have all your ones column lined up and all your tens columns lined up. Now in this case, I would add 8 plus 2 is 10, plus 5 is 15. Now I can't write the whole number 15 there because only one digit can go there. So I need to take this 1 here and carry it over to the next column, where we would then add 1 plus 1 plus 1 makes 3 and have 35. Basically, think of this like adding pennies. If you've got 15 pennies, you'd like to buy a dime with them. So you trade out those 10 pennies that we move over here, they become 1 dime, and all those dimes get added in the tens column. Now let's add something a little bit larger. 5,037 plus 895. Notice how I've lined up the columns. 7 plus 5 is 12. I'm going to only write the 2 down, carrying the 1 part of the 10 to the next column. 1 plus 3 is 4, plus that 9 is 13. We only can put the 3 down, carry the 1 to the next column. 1 plus 0 is 1, plus the 8 there is 9. And then we add down 5932, 5,932. Now, I don't want you going to a calculator here. The purpose of this course is to make sure you've got all your arithmetic down. Later on, a couple classes from now, when we're focusing on algebra, that'll be time to use your calculators. But for now, we want to focus on the skills you need in this class. Now let's look at a few properties of addition. They may seem rather basic, but we want to describe this and have this vocabulary understood and part of our working vocabulary. The first one is the addition property of 0. That basically says if you have any number, which I'll call x, and you add 0 to it, you basically get back to x that you began with. In an example, I could say that 9 plus 0 is equal to 9. Notice how when I describe a property, I'm using variables, meaning it's true for any number that I substitute in for that variable, whereas over here when I use numbers, it's not the property itself, but it's an example of this property over here. Then we have the commutative and associative properties of addition. Anytime I see the word commutative, I think of the word commute, and I think of people who are commuting back and forth to work. They're moving their location. Here I'm going to say A plus B is equal to B plus A. In other words, I can move the numbers around when I add them. As an example, I could say 7 plus 2 is equal to 2 plus 7. Now, the associative property, I always think of the word association when I see the word associative. An association is a group that you might belong to, and group is the key word here. I can group the numbers how I want when I add them. For example, I can say A plus B added together, then adding C on is the same as A plus grouping B plus C together. Notice that ABC is in ABC order on each side of the equal sign, and the order has not changed, but the parentheses, how we grouped them, has. For example, if I add 7 plus 4 and then add 3, that's the same thing as starting with 7 and then adding 4 plus 3. The first time on the left, I'm getting 11 plus 3, which is 14, and on the right, I'm getting 7 plus 7, which is 14. The left side and the right side are both equal to 14. We're just basically putting some words to some concepts that you should already be familiar with. Now let's talk about perimeter. Perimeter is an addition word. Basically, the perimeter of a shape is the distance around the shape. Now you might think of this as how far would an ant have to walk to get around the shape, starting at one point and going fully around the shape. Now usually when we talk about rectangles, we use the words length and width. and there are 2 lengths and 2 widths. So we have a formula here. We can either go perimeter is equal to W plus L plus W plus L and add those up, or we can say we're going to have 2 of our widths plus 2 of our lengths. When we have a square, all 4 sides measure the same thing. And you could say that the perimeter of a square is side plus side plus side plus side. Or since all of them are the same, you can say 4 times that side, whatever that side is. If you have a funky looking shape, I'd actually have to give you the measurements for each of these sides, and you would add those values or those lengths together to find the perimeter. In section 1.3, when we get to subtraction of whole numbers, I want to first comment that subtraction is not commutative. If you have 7 minus 4, you get 3. But if you reverse the order, 4 minus 7, you don't get 3. You end up getting negative 3. So subtraction is not commutative. You cannot move the numbers around when you are subtracting. Now, we're not going to get into negative numbers until the end of this course, but this is a key concept that you need to have with you through all your math classes as you continue on. It's really important in algebra. Now let's turn our attention to subtracting, and I'm not going to do a lot of simple problems. Let's just go straight to something like 2,163 minus 847. Notice how I have all of my columns lined up, and I start in the ones column at the far right. 3 minus 7. I can't subtract them. I've got to do some borrowing. That's like saying I can't take 7 pennies away from 3 pennies. So I've got to come over here to the dimes, take away from the 6 dimes, drop it to 5 dimes, and take that 1 dime and move it over to the next column as 10 pennies. I now have 10 pennies plus the 3 pennies, making 13 pennies. Now 13 minus 7 is 6. I move to the tens column. 5 minus 4 is 1. We move to the hundreds column. I cannot go 1 minus 8 and get a positive number. So again, I've got to do some borrowing. Borrow from the 2, make that 1, and move 10 of those over to the next column. So I have 11 minus 8 is equal to 3, and then 1 minus nothing is 1. So I have 1,316 as the difference here. Now the opposite of subtraction is addition. So if you want to take the 1,316 and add the 847 back on, you should get back to the 2,163 as the total. Subtraction and addition are opposites, so subtraction can be checked through addition. Now let's talk about some words that mean subtraction. Obviously we've got subtract and subtraction, and you've got words like minus and take away, etc. We also have the word decrease and the word less or less than. And I really want to pay attention to this word less and less than, because we can get in ourselves in some trouble here by getting numbers in the wrong order. If I have something like 4 less 7, basically I'm saying I want to start with 4 and take away 7. That becomes 4 minus 7. But if I say 4 less than 7, it almost implies, well, it does imply, that we're starting with 7 and we're taking 4 less than that. And that becomes 7 minus 4. Now, I wish I could tell you that just the word than is what tells you to reverse the order, but the English language is a little bit screwy here, and you always have to, with subtraction, be careful to ask what is being subtracted from what. These words right here are going to be with you through all your math classes, and you really want to be on the lookout for them. If you're asked to put something like the phrase, the difference of a number and 6, into some algebraic form, I want you to pay attention to this phrasing, the difference of. You know, after the difference of, you're going to have this and that. Well, it's this, the number, and 6, that. This and that. The this goes first, the that goes second. So this is going to be a number, I'll just call it x, minus 6, instead of 6 minus x. I've already told you subtraction is not commutative, and 6 minus x and x minus 6 are not the same. If we were adding x plus 6 and 6 plus x, that would be the same. Now, you're not going to have algebra right now. Okay, right now this is an arithmetic class with algebra to come, but I want to call this to your attention because it fits right in here with this whole subtraction concept. We've got subtraction of whole numbers now. Later on we'll have subtraction of fractions. Then we'll have decimals that we're subtracting, and then we'll deal with adding and subtracting positives and negatives from each other. So this is going to keep coming up throughout the course, and at some point we're going to lay into the algebra. In this next section, we're going to talk about rounding. And rounding, a lot of people say, oh, I've got that, that's easy. But you know what? When we really get down to it, we tend to have some problems. Let's say I have the following. Let's say I have 26,984. The rules for rounding require you first to identify what digit you're rounding to. So if I'm rounding this to the nearest 10, for example, I would need to identify the digit that's in the tens column. That would be the 8 in this case. And then after I identify what digit's there, I look at the position after it, which is the 4, and that's going to help me make my decision. When it's 0 through 4, I round down, and so that 4 is going to turn into a 0, and I'm going to have 26,980. Had that 4 been a 5 through 9, we would have rounded up. So I'm going to change this right now. I'm going to erase that off, and instead of rounding to the nearest 10, we're going to round to the nearest 100. Well, I want to first identify the digit that's in the hundreds column. That's 9. And then the 8 after it then helps me decide whether to round up or down. Since that's in the 5 through 9 category, we're going to round up. Well, when I round up, that means take this 9 and change it to a 10. But changing that 10 means, uh-oh, I've got to carry over here. And so I'm going to end up having 27,000. Notice that 9 became a 10, which was our 0 here, and all the rest were zeros. So even though I was rounding to the nearest 100, I also ended up rounding to the nearest 1,000 at the same time. And that's one of those tricky things that you've got to be careful of. Anytime you are rounding down, the question mark digit tells you just erase it and turn it into a 0. But whenever you're rounding up, the target position increases by 1, and then the rest becomes zeros after that. So this became the 10 followed by zeros, but the 10 had us carry that 1 and change the 6 into a 7. Now, when is rounding important? I use rounding all the time when I'm going shopping. Let's say I've got a budget of $150 when I go to Walmart. I don't want to keep track of every single thing as I put them in my cart, so I'm going to probably round to the nearest dollar. If something is $1.39, I'll round it down to $1. If it's $6.72, I'll round it up to $7. And that way I can just keep a track of all those rounded numbers and add those up and kind of keep attention to where I'm at, so I don't go over the budget that I have. So that's kind of a place where rounding is used in a real life setting.